Dear students, from this root math channel, now you are going to learn how to find the highest common factor of given numbers. Do you think finding the highest common factor is really hard? Let's learn the lesson from this channel. At the end of the lesson, you have a chance of check yourself. First, you want to know what are the factors of a number. By multiplying two numbers, we'll get a whole number. The answer what you are getting is known as the product number. For example, 7 multiplied by 3 gives you 21. This 21 is known as the product number, and the 7 and 3 are known as the factors of 21. What does mean by factor? The reason numbers, by multiplying those numbers, the 21 is coming. So the factors means by multiplying which numbers you are getting the answer number or a product numbers are known as the factors. For example, for 21, not only 7 multiplied by 3 you are getting 21, but one time of 21 also 21. So when we are listing out the factors of 21, we want to include 1 and the number itself. So the factors of 21 are 1, 3, 7 and 21. So how to identify the given number is a factor of the answer number or any composite number? Just take the number and divide and see. If the given number divides the product number completely, then the number is a factor. For example, 21 can be completely divisible by 3 as well as by 7. So 7 and 3 are the factors of 21. Here, the factors of 16, you are asked to list out. How to write the factors of 16? Just you think of the times table. Start from the timetable 1. In the timetable 1, it's coming 1 time of 16 is 16. Since 16 is the even number, definitely it comes in the second table. 2 times of 18 is 16. And in the third table, 16 is not there. Go to the fourth table. 4 times of 4 is 16. We know that after the fourth table, we can't see the 16 as a product number in any other table. So we are stopping here. So what are all the numbers you have chosen to multiply and to give the product number as 16? These numbers are known as the factors of 16. So the factors of 16 are 1, 2, 4, 8 and 16. These numbers are the factors. So for any number, 1 and the number itself are factors. Shall we try with the 56 now? We'll start from the first timetable. 1 time of 56 is 56. Yes, 56 is an even number. So definitely in the second table, 2 times of 28 is the 56. In the third times table, it's not coming. So in the fourth times table, 4 times of 14 is 56. And seventh table, 7 times of 18, 8 is 56. Here you can see the factors of 56 are 1, 2, 4, 7, 8, 14, 28 and 56. So these are all the factors of 56. Here I am stressing the word factors. But we are in our textbooks, we can see prime factors. Then what are the prime factors? So before you get to know what is prime factor, you want to know what is prime number first. So what are the prime numbers? The prime numbers are whole numbers greater than 1 that have only 2 factors, 1 and the number itself. Just now you have learned how to write how to identify the factors, correct? If I am choosing 2, the 2 I can get by multiplying 1 and 2. 1, 2 is 2. Other than the first timetable or in the second timetable, 2 times of 1 is 2, I can't see this 2 as a product number in any other times table, which means that for the number 2, the factors are 1 and 2 only, which means 1 and the number itself. So these type of numbers are known as the prime numbers. So what can be my next prime number? 3. So for 3 also, 1 time of 3 is 3 or 3 times of 1 is 3. So for 3 also, there are only 2 factors, 1 and the number itself. These type of numbers are known as the prime numbers. Here, the prime numbers are divisible only by the number 1 and by itself. Here, I have shown you the list of numbers from 1 to 100. The shaded numbers are the prime numbers. Here, 2 and 3 we already discussed. What about 4? 4 is a composite number. Why? Because in the first timetable, you can see 1 time of 4 is 4. In the second timetable, it is 2 times of 2 is 4. Other than the fourth times table, you can see the 4 is coming in the other table, that is in the second table also, 2 times of 2 is 4. When I am listing out the factors of 4, I want to include 1, 2, and 4. So you can see other than the number and 1, 2 is there, which means 4 is not a prime number, it is a composite number. Where is a 5? 5 is 1 time of 5 is 5 or 5 times of 1 is 5. Other than these 2 times table, you can't 5 in any other times table, which means that 5 has only the 2 factors, 1 and the number itself. So 5 is a prime number. Here, you want to know one fact, like 2 is the only one even prime number. All the other even numbers are composite numbers. Okay. At the same time, don't consider like all the odd numbers are prime numbers. Okay. So here I have given you the table. There you can see all the shaded numbers are the prime numbers. At least from 1 to 100, we want to know all the composite and prime numbers. It will help you more in your lessons. What are all the factors and what are the prime factors? So just before we have learned what are all factors. Here I have given you one more example, 20. To get the product number 20, I have multiplied 4 and 5. 4 times of 5 is 20. So 4 and 5 are the factors of 20. These are all set as factors. So the factors of a numbers are that are multiplied to get the original number. Then what is a prime factor? The prime factors of a number that are prime numbers, which means the factors must be a prime number. By multiplying these prime numbers, we want to get the original number. At the same time, it cannot be splitted more as a factor. For example, 2 times of 2 is 4 and 4 times of 5 is 20. I got the answer number 20 and all 2, 2 and 5 are prime numbers. Here, 2, 2 and 5 are the factors, prime factors of 20. So there is a difference between the factors and prime factors. Whenever you are attempting such questions, read the question properly. If it is asked only the factors, you can write like this. If it is asked the prime factors, break your composite numbers again as a prime numbers and list out all the prime factors. So there are different methods to find the prime factors of the given number. The 2 methods I have discussed here, one is factor tree method, another one is prime factorization method. The first method, factor tree, find the prime factors of 36. 36. So what is the factor tree method? Which means that I'm going to divide the 36 as a product of the prime number with another number. Till we reach 1, we want to split it. Let's start. 36 can be splitted as 2 times of 18. Here 2 is a prime number. You can't split more. But 18 is a composite number. We can split it again like 2 times of 9 is 18. Again 2 is a prime number. Go to 9 and split it again as 3 times of 3 is 9. Here you can see 2, 2, 3, 3. We have arrived all of our numbers as a prime numbers where we can't split more. So the prime factors of 36 are 2, 2, 3 and 3. So we'll go and see the next example, prime factors of 108. I have chosen another method, prime factorization method. Otherwise, it's called as a ladder method. So I'm going to put 108 in a ladder. I'm going to divide it using the prime numbers only till I reach 1. So since 108 is a even number, we can divide 108 by smallest even prime number 2. So first take the first digit 1, which is lesser than 2. So take the second digit 0 also. So this is 10. So there are 5 2s are there, and in 4 there are 4 2s. So 54. And again 54 is an even number. It can be divisible by 2. So there are 27 2s are there in 54. Since 27 is an odd number, and you know that it can be divisible by 3. So 3, 9 3s are 27. Again 9 can be divisible by 3. 3 3s are 9. And when we are dividing 3 by 3, our answer is 1. Till we reach 1, we want to continue our division. Here, whatever you are getting as the divisor number here, they are set as the factors of 108. So 2, 2, 3, 3 and 3 are the factors, prime factors of 108. This method commonly used everywhere, and this method easy too. Next is list of common factors. List the common factors of 28 and 54. So how to write the common factors of 28 and 54? First, we want to find out what are the factors of 28 and factors of 54. How to find the factors of 28? I'm writing here factors of 28. I'm using the prime factorization method 28. Since 28 is an even number, I'm going to divide it by 2. 1 2 is 2, 4 2s are 8, 2, 7 2s are 14, and 7 is a prime number. You can't divide by any other number. So 1. So factors of 28 is 2, 2 and 7. Now we'll go and see for 54. 54 again an even number 2. In 5 there are 2 2s. 2 2s are 4. The balance is 1. 7 times of 4 is 7 times of 2 is 14. And 27 can be divisible by 3. 9 3s are 27. 3, 3. And 3 can be divisible by 3 by itself. So the factors of 54 is 2, 3, 3 and 3. Now what is a common factor? Common factor means the factors which is common in both the numbers are known as the common factors. So here you can see the 2 is there in both the numbers. So this 2 is known as the common factor or highest common factor, which means that the 2 can divide both the numbers without any remainder. So how to find the highest common factor? There are different methods. One method is prime factorization method. Second is single ladder method. Third is long division method. Prime factorization method. Here 24 and 64 are the two numbers given for us to find the highest common factor using the prime factorization method. I'll be taking the 24 first. We know that 24 can be divisible by 2. So 1, 2 is 2, 2 2s are 4, 2, 6 2s are 12, and 2, 3 2s are 6, and 3 and 1. So first we'll write the factors of 24 as 2 times of 2 times of 2 times of 3. And then 64, 3 2s are 6 and 2 2s are 4. 1 2 is 2. In 3 we have taken 2, 1 is there, 12, 6 2s are 12, and 2, 8 2s are 16, 2, 4 2s are 8, 2, 2 2s are 4, 2 and 1. For 64, there are 1, 2, 3, 4, 5, 6. 6 2s are there. These are all the factors of the two numbers 24 and 64. Check the common factors first and circle it. So here 2, second 2 and 2. So 2, 2 and 2. Write one number from each pair of numbers and multiply them. That is known as the HCF of 24 and 64. So 2 times of 2 times of 2, which is equal to 8. 2 2s are 4, 4 2s are 8. So 8 is the highest common factor of 24 and 64. We'll do practice on the same method for the numbers 60 and 96. We'll go to the number 60 and we'll find the prime factors of 60 and divide the number 60 by 2. 3 2s are 6 and put the 0 here, which means 30 times of 2 is 60. And by dividing 30 by 2, 15 times of 2 are there. 15 can be divisible by 3. So 5 3s are 15 and 5 can be divisible by itself. So the factors of 60 is 2 times of 2 times of 3 times of 5. And then factors of 96. The 96 can be divisible by 2. 4 2s are 8. In 9, we have taken 8. Balance is 1. 8 2s are 16. 2, 2 2s are 4. And 4 2s are 8. 2, 1 2 is 2. 2 2s are 4. 2, 6 2s are 12. And 2, 3 2s are 6. And 3 and 1. So the factors of 96 are 2, 2, 2. There are 5 2s and 1 3. Okay. Now we'll check on the common factors. Here you can see the 2 is common. Again, one more 2 is common. At the same time, this 3 and this 3 is common. So we'll write the HCF like 60 and 96, which is equal to 2. From this pair, 1, 2. And again, from this pair, one more 2. And from 3 and 3, 1, 3. So 2 2s are 4, 4 3s are 12. 12 is the highest common factor for 60 and 96. So this is the method to find the HCF using the prime factorization method. That means we are finding the factors of each number separately and we are listing out and we are comparing both of the factors and common factors have taken out and multiplied for one time. So the answer number is known as the highest common factor for the given numbers. This can be done for 2, 3 numbers also. And here the single ladder method. Single ladder method means instead of finding the factors separately, we are going to put both 75 and 90 in the same ladder. So 75 and 90 we will put in the same ladder and we can divide 75 and 90. So you can see these both the numbers can't divide by 2. 90 can be divisible by 2 but not 75. So I am going for 3 now. According to the divisibility rule of 3, 75 can be divisible. So there are 2 3s are 6 and 1 is balance and then 5 3s are 15 and 3 3s are 9. 30 times of 3 is there. And 25 and 30 both are divisible by 5. 5 5s are 25 and 6 5s are 30. Here 5 and 6, they don't have any common factor. To find the HCF using the single ladder method, you divide them not till you reach end. Where you don't have the common factor for both the numbers, you want to stop there. In that time, what are all the devices you have, that numbers or the product of those numbers are known as the HCF. So HCF of 75 and 90 is 3 times of 5, which is equal to 15. Okay. So what we are doing is we are dividing the given numbers with the using their common factors, and where they don't have the common factor, we are stopping the division and we are multiplying the divisor numbers, that is the HCF. Okay, so one more example, 36, 42 and 72. We are going to put all the three numbers in a single ladder. Since 36, 42 and 72 are even numbers, we can divide by 2. There are 18 twos are there in 36, 2 twos are 4 and 1 2 is 2. And in 72, 3 twos are 6, balance is 1 and 6 twos are 12. You can see here 18 and 36 can be divisible by 2, but 21 not divisible by 2. So, but in the third table, all the three numbers are coming. I'm going with the third table. 6 threes are 18, 7 threes are 21, 1 3 is 3, 2 threes are 6. So, here 6, 7 and 12. 6 and 12 can be divisible by 2, but 7 can't be divisible by 2, which means that 6, 7 and 12, they all three doesn't have any common factor. So we are stopping our division here. In this time, what are the divisors? 2 and 3. Multiply 2 and 3, which is equal to 6. 6 is the HCF of 36, 42 and 72. So this method is known as the single ladder method. Next method you are going to learn is known as the long division method. This long division method will be useful for the large size of numbers. Since the number size is small, like 2-digit, 3-digit number, we can use the single ladder method. And long division methods will be used for the 4-digit to 5-digit numbers to find the HCF. Here I have taken the small numbers 180 and 220 to find the HCF using long division method. In this long division method, first you want to compare both the numbers and choose the smallest number and take as a divisor, and big number you want to write like this as a dividend. Now you want to start divide. 180. There can be only one time only in this 225. By subtracting, we can get it is 45. Okay, I'm doing subtraction here. You want to see whether you got 0 here. If you are not getting 0, which means that my remainder is not 0. Correct? Since the remainder not 0, take this remainder and write as your new divisor, and your old divisor will become your new dividend. Okay, and here there are 4 45s are there in 180. You can see by subtracting 180 to 180, I'm getting 0. When you are getting the remainder as 0, in that time, what is your divisor is known as the HCF of the numbers. Okay, so first what we are doing, we are choosing the smallest number among these two numbers. The smallest number will become the divisor and big number goes as the dividend. We start to do the division. The remainder, if not equal to 0, take the remainder. You want to go to the next level of your answering. There, your remainder will become the new divisor and your old divisor will become the dividend. Continue the division. If you are getting the 0, that means as your completely divides, means in that time, what is the divisor is known as the HCF. According to the size of the number, the division may continue for 4 or 5 times also. Here comes the next example. Here I am comparing 3 numbers to find the HCF. First, I'll take the smallest number among these 3 numbers and largest among these 3 numbers as my dividend. Okay, in 170, only one time of 102 can be there. After dividing, we want to subtract it. So it is 8 and 68. You know that when the remainder is not equal to 0, our remainder want to become a new divisor and our old divisor want to become the new dividend. So 168. In 102, there can be only 168 by subtracting 4 and this 34. Again, 34 is not equal to 0. I want to continue my division. So I'm going to continue like my 34 is my new divisor and 68 is my new dividend. There are two 34s in 68. 2 times of 34 is 68. Now, when I'm subtracting, I'm getting the remainder as 0. When I'm getting the remainder as 0, in that time, my divisor is 34. So, the 34 is the HCF of 102 and 170. Now, what about the third number? Now, we'll compare this HCF and the third number. I'm taking that HCF as the divisor. I'm taking 136. That is my third number as the dividend. In 136, how many 34 can be there? Let's check with 4 times. 4 4s are 16, 1 and 4 3s are 12, 12 plus 1, 13. Yes, it completely divides. So, when remainder is 0, what is my divisor? That is my HCF. So, the HCF of 102, 170 and 136 is equal to 34. So this long division method can be used for any size of numbers, preferably for the large size numbers like 4 or 5 digit numbers. It will be very much useful. I hope you all understand the methods of finding the HCF of the given numbers. Here I have given you few questions to try yourself. And if you have any doubts, comment me. Thank you. And we will meet in the next video.